Section 4.1, Organizing Data into Matrices. For the first section of this chapter, we're going to just take a brief moment to talk a little bit about matrices, what they are, how to identify the parts of them, and how to properly write a matrix. And so I want to start by talking about the matrix itself. Mathematically, we use a matrix. It's just a rectangular arrangement that we use to organize data in mathematics. Typically, most people would compare a matrix to just putting data in a table. And the only thing I like to describe about a matrix is that it's like a table without all the lines and labels and headings and all those things that you would normally find in a table. It's pretty much utilitarian, nothing but numbers in the whole thing. When we write a matrix, we usually name it by using a capital letter, and we'll use some brackets around the matrix to show what's included within that matrix and what would not be. And within every matrix there are individual elements, and an element of a matrix would be considered one of the numbers or even variables. Your matrix can have a variable in it from that particular matrix. So let me take just a second here and show you what a matrix would look like. Again, I said I would start by using a capital letter to name my matrix, so I might use something like the capital letter M. And it says that my matrix would be enclosed with a square bracket, so I'm going to start with a square bracket here. Now I'm just going to put some numbers into my matrix, which would have been data that I had collected from something. So 4, 2, maybe -1, 0, -6, and I don't know, 12. Okay, so this would be a matrix and what it would look like. Again, like I said, it's just in a rectangular shape with rows and columns, has square brackets around it with a capital letter that is identifying the name of the matrix. Okay, then we talked about elements. Okay, so an element in this matrix would be just one number from that matrix. So for example, in my matrix, -6 would be one of the elements. This particular matrix happens to have 6 elements total. Okay, 3 rows, or 2 rows, 3 columns actually. And so those are some of the parts of things that we have in a matrix. Now, when we talk about the dimensions of a matrix, which are going to be important once we start manipulating these, and even when we start writing them, we identify the dimensions of a matrix by simply noting the rows and the columns of the matrix. Okay, so we have a standard way of always identifying the dimensions as the number of rows by the number of columns. Okay, which can get a little confusing if you're not paying attention, but when you think about rows and columns, this particular matrix here, when I talk about rows, this one has 3 rows. Rows go from left to right or right to left, whatever you want to think of it, but usually left to right. And so I would say that this particular matrix has 3 rows. Okay, my matrix M has 3 rows. And then as far as the columns, think of columns like columns on a building, so columns are going to go down this way. So this one happens to have 3 columns. So if I'm going to state the dimensions of matrix M, I would say that matrix M is a 3 by 3 matrix. Now, that would be one matrix that if you had to identify the rows and columns and you switch them, you would be perfectly fine. However, matrix N over here, on the other hand, has, if I identify the rows first, it happens to have 2 rows. And then if I identify the columns on this one, happens to have 3 columns. Okay, so this would be a matrix that it would make a difference if I happen to mistakenly label these backwards. But if I'm going to give the dimensions of this matrix, this one happens to be a 2 by 3 matrix. 2 rows, 3 columns. Now, as far as the elements themselves, we also have a notation that we use for identifying the elements specifically in the matrix. Now you'll notice that this first one here says M and then has looks like a 13 down there. But, and oftentimes instead of seeing them like this, you'll see a comma in the middle of these here, like this. But what this is asking me to do, and it's using a lowercase m, because we're talking about a single element out of the entire matrix, but it's asking me to find in matrix M, okay, so the matrix that's called M, find the element that is in row 1, column 3. So to do that, if I look up at my matrix M, I find row 1, column 3, row 1, column 3, and I find the element 3. So if I'm identifying the element that's at M13, I would say it is a 3. Now if I finish up my other two examples here, M22 is row 2, column 2, and you'll see that that is a 12, and M31 would be the element that is in row 3, column 1, so I would say that that is going to be a 9. Okay, so you may see them with a comma between the two numbers, you may not. It doesn't matter either way, you're going to have the same thing, row first, column second, when you find those. Okay, so since we talked about a matrix being a way to organize data, here's an example of some data that was collected that we need to organize into a matrix. So for this matrix, they want us to write a 2 by 3 matrix. Not every time do they specifically give you a matrix size that they want you to use, but I need to stick with that on this problem. And it says it needs to be 2 by 3, which means 2 rows. Okay, so I need to have 2 rows, and I need to have 3 columns. If they were not specific, I could make this matrix whichever direction I like, 2 by 3, 3 by 2, however you want. So what I probably need to do is identify, if I'm going to have 2 rows, in the information that I have in the table to the left, what information comes in 2. And I can see 2 things. I see that I have 3 players, and I see that I have wins and losses. So what I'm probably going to do is use the rows to represent the number of wins and the number of losses. And since I have to have 3 columns, I'm probably going to let the columns represent the players. Now, since this matrix I'm using to represent some actual data that I have, and just to make it a little bit easier to set up my matrix, I'm just going to use some little labels here. Since my rows are my wins and losses, I'm going to put wins and losses there just to help me set this up. And then my columns are supposed to be my players. So my players are Ed, Joe, and Lou. So I'm going to put those labels there just like that, just enough so that I can set up my matrix with my numbers. So if I'm looking at this first place, this first element in my matrix, it looks like it's going to be in the first row and the first column. And the first row representing the wins, and the first column representing Ed. So what I will probably do is come over here to my chart, and I will find how many wins does Ed have. And Ed has 1, 2, 3, 4, 5 wins. Okay, so if Ed has 5 wins, I'm going to come in here and I am going to put a 5 in the first element for Ed's wins. Okay, now I'm actually going to move down and I'm going to go to row number 2, and I'm going to finish up with Ed here. Ed has 5 wins, but in row number 2 I need to put his losses, and I see that Ed has 1, 2 losses. So over here under Ed's losses I will put a 2, and I'm just going to continue that for both Joe and Lou. So when I look up Joe and I do row 1, column 2, Joe has 1, 2, 3, 4, 5, 6 wins, and it looks like he has only 1 loss, so I'll put a 1 down there. And then finally for Lou, Lou has what looks like 3 wins and 4 losses. And there's my 2 by 3 matrix. It has 2 rows, 3 columns, and I can change that around if I need to. So for example, if they ask me to make this same data into a 3 by 2, how would I change this data? So changing it to a 3 by 2 simply means I need 3 rows and only 2 columns. So I just take my information and sort of flip-flop it here. So what I will do is make my rows be my 3 players, and these be my wins and my losses. So I'll take the same information, Ed's wins, Ed's losses, Joe's wins, Joe's losses, and Lou's wins and Lou's losses. So same information, just a little bit different format depending on how you want that data organized. All right, so what I'd like to do, just a couple of questions for you to ponder before we move on. If I'm working with this situation about the wins and the losses, what do you think would happen, or what could I do if I had a second matrix created with wins and losses after they went to another tournament? Would I want to set my matrix up in the same format as I had previously? Would it make a difference if I set it up in a different format? What would you do if you were setting up another matrix to represent another tournament? Second question I want you to consider is, how would you combine this information together and keep track of total wins and losses? If I had 2 matrices, how could that information be combined together to make a matrix that keeps track of total wins and losses from all tournaments instead of having a separate one for each tournament?